find out the current in each element if all elements are connected in the parallel combination. Apart from this, we have seen the delta and star connections. Sometime in the circuit where we can't identify the combination of the elements, whether they are connected in the series or parallel, the delta and star connection are very useful there. Last time I gave you one homework also. If you people did that, so in that also there is a lot of application of star and delta connection. Okay, if you people didn't do that, today I'm going to do for you people. Okay, so here we go. The first example we already attempted this, and the second one is asking obtain the equivalent resistance for the circuit in the figure and use it to find the current I. Our task is to not only to find the value of current, but to so this is the question. Come to this circuit, I'm drawing it on the blank page over here. Our question is, we have to find out the R equivalent as well as the current in the circuit also, and the given circuit is 12.5, 15, 5, 10, 20, and here 30 ohm. These values are in ohm. Okay, and here this is the A and this is B. Okay, connected with 120 volt battery. I think here also one resistance is given. Okay, we'll check the value later. We have to find out the equivalent resistance of this circuit across terminal A and B. So here you can clearly see that we have to start from the ending portion of the circuit. Here this 30, 10 and 20, they are not connected in the series combination. They are not connected in the series combination. No series, no parallel. See, you can clearly observe this 30 and this 10. Are they connected in series combination? No. Are they connected in parallel combination? No. Though the starting point is same for these two resistances, but the ending points are different. And for the parallel connection definition, the ending points and the starting point should be same for elements which are connected in the parallel combination. The same thing is with 20 and 30 also. No series, no parallel, nothing. So tell me, which type of connection is this then? Is this star connection? No. Is this delta connection? Is it not clearly visible, right? But we can make it visible. See, suppose this is the point A, this is point B, and this is point C. I can redraw it. C, A and B. Between C to B, this is the whole same point. Okay, C to B we are having 20 ohm. Okay, fine, 20 ohm. Between C to A here I am having 10 ohm. Okay, fine, 10 ohm. A to B I am having, tell me, 30. Okay, 30, fine. This is clearly given. This is the delta circuit. So if you will resolve this circuit into star, maybe it will be beneficial for us to solve the circuit. Let's check it. Our task is we are going to convert this into equivalent star. Okay, remember this is the equivalent star. Equivalent star means this conversion is not going to making any change to the circuit. Everything will remain same. Just delta into star means suppose you are having 100 rupee notes, you are going to taking the change of these notes, 50 rupee notes. Simple, you are going to do this only. Okay, so the value of this, suppose this is R1, the value of R1, tell me 10 into 30. Remember or not? 10 into 30 divide by the summation of all 30, 50 and 60. So your result is 30 to the 5 ohm. This is 5 ohm. Okay. This one is 5. What about this? This one. Take it R2. R2 is nothing but 20 into 30 divided by 60. 30 to the and 2 10 ohm. Okay, fine. Come here. Suppose this is R3. So R3 is nothing but 10 into 20 divided by 30. Sorry, 60. 23 is so this one is the 10 by 3. Is it okay? So I'm drawing this over here in the circuit itself. Now you are having this branch 5 ohm. This branch you are having 10. Yes, absolutely. This is 10. What about this? This branch you have 10 by 3. Okay, 10 by 3. Now you can remove the delta connection, which is previously we have. I can remove this. Now this one is no longer exist in the circuit. Now your circuit become like this. The circuit become like this. Now tell me, in this resultant circuit, this 5 and 10, these are in series? No series. Why? Because in between them, another branch is connected. Okay. So, they are in parallel? No, they are not in parallel. But inside this 5 and 10 by 3, these are in series combination. So, we can simply add 5 plus 10. Okay. I'll remove this portion. Okay, fine. Now, this 5 plus 10 by 3, they are in series combination. So 5 plus 10 by 3, simply we can add them and the value will be 15 plus 10 divided by 3. So we are getting 25 by 3. So I can replace this whole branch by 25 3 only. Any problem yet? Good. So I can replace this branch by the new one, and that is 25 by 3. This is 25 by 3. Now see, this 5, this 10, this 25 by 3, they are in what? Series or parallel? Nothing again, but they are making the star connection. So if they are making the star connection, so we can easily convert into delta. Maybe when we are going to convert into delta, and at the end the delta will be beneficial for us to solve the circuit. That's why we are going to convert it. Okay. So our task is, we'll convert this star in delta. This is the delta. This is delta. Tell me the value of this delta RA. This is suppose one value RA. This RA is nothing but 5 plus 10. 5 plus 10 plus multiplication of both divided by the remaining branch. 25 by 3. By 3 will come here. So you will be having 5 plus 10 plus 25 to the 50. 25 to the and 6 plus 6. So you are having 21 ohm. So you can write over here 21 ohm. 21 ohm. Is it okay? Okay, then remove this. Remove this. Okay. Fine. Come to this one now. Okay. Okay, fine. This is nothing but this is going to connect with 25 by 3 plus 10, 25 by 3 plus 10 plus multiplication 20, 50 by 3 divide by the third branch, and that is 5. Any problem yet? 25 by 3 plus 10 plus 25 by 3 into 10 divided by remaining branch, and that is 5. So you are having final 25 by 3 plus 10 plus 5. 5s are 50 by 3 here, 50 by 3 here. So finally you are having 25 plus 30 plus 50. It means 105 by 3 you are having. Is it correct or not? Tell me. 75. Okay, correct. Now this 105 divided by 3. So 3s are, 3 are 9, 3 5s are. So this is nothing but 35 ohm. Is it correct? Okay. Then I'll erase this part. Okay. Now, friends, we are having the third branch now. We have to calculate the value of third branch. Okay. Come to the third branch. Wait a minute. The third branch is this one. And the value of this is nothing but 25 by 3 plus 10. 25 by 3 plus 10. No, not 10. Plus 5. 25 by 3 into 5 divided by the remaining branch, and that is 10. Any problem? No. This is 5 2s. So this is 25 by 3 plus 5 plus 25 by 6. So when you will take the LCM, we are having 50 plus 30 plus 25, again 105 by 6. Right? So this time when you will divide, you will get 17.5. So this is nothing but 17.5. Now you converted the delta into the star. Now we can remove the star here from the circuit. Is it okay? Now this is your resultant. Remove this. This is your new circuit. Okay, this calculation also I'll erase. So this is your new circuit. Now see how these elements are connected, series or parallel or whatever. See. Now if you will observe this circuit. So we are having now, wait a minute, this 17.5 and this 12.5, they are in parallel combination, because this is the starting point of these two, this is the ending point. They are in parallel connection. They 15 and 25, they are also in 15 and 35, they are also in parallel connection. So again we can resolve 12.5 into 17.5 divide by 12.5, 17.5, how much will get? 30? Yes, 30 absolutely. So we'll be having some value. It's now depend on you. Please calculate and give me the result. Now what about this? This will be 15 into 35 divided by summation, and that is 50. Is it okay? This is also value. This is A, this is B. So I can replace this 2 with a single branch. Okay? Single. This is the single branch, and the value of this branch is A. Okay. Now this one also, this combination also resolved into one branch, and the result of that branch is B. Is it okay? This is B. Now A and B, they are in series combination, so I can write A plus B. Now A plus B in parallel with 21. So A plus B is parallel with 21. Again you have to calculate this value. Once you will get this value, let's take it C. This C will be connected with this resistance. So the R equivalent we can find easily. Okay. Now it's for you. I'm giving you homework. Okay. So finally, once we are having only one resistance in the circuit, and that is R equivalent, and you are having the battery 120 already given, simply the Ohm's law, I is nothing but 120 divided by R equivalent, whatever you will get here. Is it okay? Good. Come to the next now. Come to the next topic, and this is the last topic of the unit, delivering and absorbing power by the source. See friends, I'll tell you first what is the power, and then we'll come to the absorption and delivery of the power. Friends, power is nothing but V into I. This is the mathematical term. In a resistance, suppose the current I is flowing and terminal voltage is V, then the power absorbed by R is nothing but V into I. Okay? In other words, I can take it like, what is V by Ohm's law? See, by Ohm's law, V equal to Ri. Is it correct? So can I replace it V by Ri? Yes, I can. Ri into I is already existing. So V is nothing but Ri square also. V is nothing but Ri square. Unit of the power is watt. Okay. Again, for the same V into I, this I can replace by V by R by Ohm's law. V into V by R. So finally you are having V square by R watt. So I am having three formulas for power. P equal to VI, R, I square R, or you can take V square by R also. Is it okay? So this is power. Okay. By the definition, the power is energy per unit time. See, in the circuit, in this circuit we are transferring the energy, right? So the power is nothing but the energy transfer per unit time. Okay? And the unit of power is watt. Now this one is not important because this is the basic. The importance is, the important things are, suppose in the circuit we are having some elements, maybe it is resistance, and maybe the other one is a independent source, battery. So power is actually two types. It may be delivered power or absorbed power. Okay. The power in the electrical circuit, the power can be delivered or the power can be absorbed. Is it okay? So now the question is, who delivered the power and who absorbed the power? Okay. So the sources that deliver the energy, actually, they are power delivery sources, but in one condition. See, suppose this is the independent source. What will be the direction of current? This is the direction of current, right? Means this voltage source or independent source is supplying energy to the circuit. Okay. And energy supply per unit time is nothing but the power, as we know. Means if this current will go to the circuit and will come again. So if in the source the current flows from negative terminal to positive terminal. See, the current is flowing from negative to positive, na? So in the source, if current flows from negative to the positive, so this power is the delivered power. Delivered power by source. This is the delivered power by the source. Is it okay? But instead of this, the current is coming into the source. Suppose instead of this, the current is coming into the source. the situation is like this. The current is coming into the source. So this source is not going to provide the energy to the circuit. It's taking the energy from the circuit. So this energy is the absorbed energy. Absorbed energy. Is it okay to you people? Now this is all about the source, but what about the elements? These elements always absorb the energy or dissipate the energy actually. Dissipate the energy. Energy dissipation we call it. Any element will consume the energy and will dissipate it. Dissipate in the form of heat and something. Okay, means they are going to spend the energy, all energy. So all elements only dissipate the energy, or we can say absorb the energy. They are the energy absorber and the sources are energy provider. But in this condition only the source is the energy provider. In this condition the source is absorber. Okay? Come to the problems now. So friends, this is all about the theory part. And now onwards we are switching to the practice session. Okay? So the first problem is find equivalent resistance between the terminals A and B and assume all resistors values are 1 ohm. These resistances are having 1 ohm. 1 ohm, 1 ohm, 1 ohm, like this. I'll draw this circuit on a first page. The circuit is, wait a minute friends. In the given circuit I am having 4 ohm resistance, battery over here, input battery V in, whose value is given at 20 volt. In this current I1 is flowing. This circuit is connected further. This is the dependent source, clearly you can see this, and this is the voltage source, current control voltage source, because the value is depending on the current. Okay, the very next resistance is 6 ohm, connected like this. Again the last circuitry is, this is nothing but the 4i2. Here 5 ohm resistance is there, and I'll take the various currents in the circuit. See, here is the current I1, this current is I2. Okay, this current is output current, and voltage across 5 volt is V out. And the question is asking that find out output current and output voltage. Our task is to find out the I output and V output. Okay friends, so this is the question in which we will move forward by step by step. Okay, see this, see in this circuit, can I apply KVL here? I know the current I1, so I'll start from this. I'm ending at the positive terminal, so this is plus 20. I'm moving forward. Here the voltage drop is like this. Is it okay? Because this is the current direction and this is my direction to read the mesh. So this is with a negative sign 4i1. I'm coming here and again this is 0. Is it okay? So from this equation 4i1 equal to 20 and I1 equal to 5. Once you get the value I1 equal to 5, you by default know now the value of 6i1. 6i1 become now 30. So this voltage source become 30 volt now. See, this is the dependent voltage source. Current control. Now once you find the value of current, just multiply it. So you can get the value of output 30.
Okay, now again apply KVL here. In this mesh, your current is I2. Okay, I'm starting from here. I'm getting plus 30. I'm moving forward in the circuit. I'm getting here voltage drop. The direction of the voltage drop will be like this, and the voltage drop will be 6I2. Is it okay to you people? I'm coming again to the circuit. See, if we analyze the circuit, we start from one point in the circuit and come back to the particular point only. So see, this is the closed path and equal to 0. So 6I2 is nothing but 30. So I2 is nothing but, I2 is also 5 ampere. Okay, once you get the 5 ampere, you directly get the value of this dependent source, because this dependent source is depending on the I2. So the value of this is 4 into 5, 20 ampere. So this source current is nothing but the mesh current, I out. Okay, this current is flowing in the circuit. So I out is nothing but directly 20 ampere. Is it correct? Now can you find out the V out? Simple. You have the current, you have the value of resistance also. 5 into 20 is nothing but 100 volt. Simple. This is your problem. Come now, next. Consider the circuit in the figure 3.38. This is your circuit. Find powers involved in each of the 5 elements and whether absorbed or generated. See, this is the circuit. 4 ampere, 4 ohm, 12, 3 and 6. So, our task is to, So again I'm taking this circuit on a fresh page. See here. This is nothing but 4 ampere. Okay. Connected in parallel with 4 ohm resistance. 4 ohm resistance. This resistance connected with a battery or independent source whose value is given as 12 volt. Fine. This circuit is further connected with 3 ohm and the current in the circuit branch is 6 ampere. Is it okay? This is the closed circuit. Fine. Now he is saying that the question is find out the power in various branch. Power in all branch. Okay. So we'll see the power. Fine. Now see, if we will observe this circuit carefully, no need to go for the whole node analysis. Directly we can find the currents in various branches. So once we are able to find the currents and voltage in the all branches of the circuit, so power we can calculate easily. V into I is nothing but power. Okay. So if you are able to get, see, 4 ampere is given. If you are able to find out the voltage across 4 ampere, so you can find out the power over here. If you can find current in this 4 ohm resistance, so easily you can find out the power drop. If you are able to find the current in this 12 volt battery, you can again find out the power, and here also we can find out the power. So see this circuit. I'm going to analyze this. Okay. See, this is the point A, this is point B. Okay, fine. So this point, these are same point. Why? Because they are connected with a wire only. There is nothing, any other element in between them. Okay. So this 12 volt is nothing but in between A and B. Means the same 12 volt is here also. the same 12 volt is given to across 4 ohm resistance or not? And if this point and this point are same, so I know the voltage drop across this current source also 12, all are same. Is it because, see, this 1, 2, 3, this all 3 branches are connected parallelly. Starting points are same, ending points are same. So the voltage drop across one branch will be the voltage of another branches also, because they are connected in parallel combination. Okay. Now, if the voltage drop across 4 ohm resistance is 12, can we find out the current? Ohm's law simple, V equal to Ri. V is given 12, R is given 4. So current in this circuit is 3 ampere. So we can easily calculate the power here. We can easily calculate the power in this branch also. What about this? We need current here. So easily we can find out the current. See, at this node A, what is the KCL? See, KCL at node A. 4 ampere current is coming. Here 4 ampere current is coming. Is it? 6 ampere current is going in this branch. 6 ampere. This point is same to this point. Okay. I need current in this. So apply the KCL here. Incoming current negatives. Minus 4. This one. Plus 3 outgoing. Plus 6 outgoing. Plus I equal to 0. So minus 4 plus 3 minus 1 plus 6 plus I equal to 5. I equal to minus 5. Minus 5 ampere. Minus means I have to change the direction. Okay. This direction is wrong. The actual direction is from this side. This minus indicates. So I'll remove this, the previous one, because this is not the original direction. The original direction is here. Is it okay? So the value of this current I found 5. Now you can find out the power over here also. Is there any problem with you? No. Now you can find out the power in this element also. But you can't find out the power in this 6 ampere. Why? Because you need voltage here. So can we find out the voltage here? Yes, I can. I'll apply the KVL in this mesh. In this mesh, I'll apply the KVL. See, this one. Okay, how? See, I'm getting 12 voltage. Yes, 12 voltage is the drop. I'm coming over here. Here the 6 ampere is going in the circuit. In this branch 6 ampere is coming and 3 is there. So here I'm having 18 voltage drop. The outer sign is negative. So minus 18. Okay, here I'm coming. I'm writing the voltage equation. So what is the voltage across this? V. So minus V equal to 0. So this is minus 6 minus V equal to 0. V equal to minus 6 volt. Minus indicates that the direction I choose is wrong direction. I have to change it. So original direction will be, this will be at higher potential, this will be at lower potential. Okay. I'll erase this part. This is the original direction. Okay, are you getting? And the value of the voltage is nothing but 6 volt. Everything is there. We find out the current and respective voltage across all elements in the circuit. Now we can easily find out the power in all elements. Is it okay? How? See. Let me erase it first, then we'll start the power calculation in different elements of the circuit. Okay. So come to the 4 ampere first. Let me change the color also. Okay. This 4 ampere. See, the 4 ampere is like this. 4 ampere and direction of voltage like this. Okay. So the power is, tell me the power. 12 into 4, 48 watt. Now we discussed already that power is always two types, delivered power and absorbed power. So what about this? This power is absorbed power or delivered power? Tell me. See the direction of current. If instead of this 4 you are having only 12 volt battery, what will be the direction of current? Tell me. If you are having 12 volt battery, the direction of current will be from positive direction. Na? This will be the current direction. Is it okay? If you are applying one 12 volt battery here, what will be the current direction from positive terminal to negative terminal? Yes. So current direction is for this way. So this is the delivered. We discussed about this. If we have a source and from that source we are getting current outside in the circuit, it means it's delivering power. So this power is the delivering power. Is it okay to you people? So this one is over. Here the power is 48 and the source is delivering the power. I hope this one is clear to you. Okay. Now come to the next branch. Next element actually. Okay. Here is it. Now the next one is this 4 ohm resistance. Okay. This is the 4 ohm resistance. Okay, fine. In the 4 ohm resistance, the current is coming 3 ampere. And this is the 4. We discussed the power is nothing but I square R. Is it okay? 3 types of formulas we discussed there. I square R, V square by R and VI. So what is the I? 3. 3 square into 4. This is 9 into 4. This is 36 watt. Is it okay? So this element is dissipating 36 watt power. And I told you that resistive element always dissipate the power. So this is the absorbed power, you can say. The power is absorbed power. This is the delivered power. I hope this one is also clear to you. Okay. Now come to the next. Come to the independent source, voltage source now. Okay. The independent source is given like this. Like this. The value of this is 12 volt and current in this branch is given by 5. So again the calculation of power is easy. 12 5s are 60 watt. But what about the power delivered or absorbed power? I told you the direction of current from the source is outer. This current is the outgoing current, means this source is delivering the current to the circuit. It means it's delivering the energy to the circuit. So it always delivered power. So the power over here is 60 watt. Delivered power. I hope this one is also clear. Now come to the 3 ohm resistance. This is the 3 ohm resistance. The current in the 3 ohm resistance is 6. So the power is I square R. I square is 6 square into 3. 36 into 3. 6 3s are 8. Oh sorry. 18 1 108. 10 watt. Power dissipated. 108. Sorry. 108. Absorbed power. Dissipated power. Come to the 6 ampere now. Here I'm checking. This is the 6 ampere. Okay. And the direction of battery is here like this. 6 volt. Current direction is from positive to negative. Means the source is also delivering the power. And delivered power is nothing but 6 into 6. 36 watt. This is delivered power. Is it okay to you? Is there any problem? Come to this now. The charge entering a certain element is shown in figure. Find the current at t equal to 1 millisecond, t equal to 6 millisecond and t equal to 10 millisecond. See friends, they have given the value of charge. So we should know first what is the relation between charge and current. As we know, current I is nothing but dq by dt. Rate change of charge is nothing but current. So we are having Q. So can we find out the value of I, current? This is the time dependent quantity. So my current will also IT dqt by dt. Now see, the first they are asking find out the current at t equal to 1 millisecond. See, at t equal to 1 millisecond here. This is t equal to 1 millisecond. Correct? Here we have to find out the value of current over here. So we should know first what is the equation of this charge here between 0 to 2. Okay. If you find out the equation for charge in this region 0 to 2, so it will be, what is the slope? 30 to 15t. It will be 15t. Okay. So at 1 millisecond, the value of the charge is 15t. So the current will be, here I am writing, the current will be d by dt and d by dt of 15t. Is it okay? And where you are going to calculate t equal to 1 millisecond. Correct? So when you differentiate 15t with respect to t, you will get 15. This 15 is nothing but the value of current at t equal to 1 millisecond. And IT, the unit of the IT is given as the ampere. Is it okay to you? Good. Is it okay? Now come to the second question. Second question is, again, find out the current at t equal to 6 millisecond. So, in the second question, the value of charge at t equal to 6 millisecond is nothing but the 30. Is it okay? At t equal to 6 millisecond. What is the value of charge? Yes, it's 30. So tell me the current. Current is nothing but d by dt of 30. This is the constant, and differentiation of the constant quantity is nothing but 0. So here at t equal to 6 millisecond, the value of the current is nothing but the 0. Here the value of current is 0. Here the value of current is 15 ampere. Is it okay? Now come to the t equal to 10 millisecond. Here is the 10 millisecond. Here at t equal to 10 millisecond, the charge equation is given by this, right? And the charge equation, when you will find out, this is the line passing through 2 points, right? 8 and 30 in milli they are given, and this is 12 and 0. Okay. So it will be, what is the negative slope over here? 30 divided by 4. So minus 30 divided by 40. This is your charge given here in this region. So the current in this region is nothing but minus 30 by 4 ampere. Okay. When we will differentiate it, this t will be gone out and we will be having minus 30 by 4 minus 30 by 4 ampere is the current. I hope this one is clear to you. Now come to this. This is the very interesting problem because we are having here dependent source application. Okay. So come to this. So the given question is, this is 12 volt, sorry, 4 ohm resistor. Okay, fine. Next, dependent source, voltage source, value is given as 2V0. So you remember which type of dependent source is this one? Voltage control voltage source. Okay, fine. Next, the battery of 4 volt. Here we are having 6 ohm resistor and the voltage drop across it is V0. like this, they are already given, and the current in the circuit is given I. Now question is find I and V0. Okay, this I and this V0 we have to find. Simply we are having only one mesh here. We can apply KVL over here. Is it? It will be simple to apply the KVL. The current direction is already given. Now we'll choose the mesh direction. A, B, C, D. So the by mesh analysis, okay, or I can say by KVL. By KVL in A, B, C, D, A. Is it okay? This is the closed path. So we'll start from the A. The voltage drop across 4 is, tell me. The voltage drop across 4 will be like this. And the value of drop will be 4I. Negative sign. The outer sign we consider in the equation. Now come here. I am getting voltage. Minus polarity is the out polarity. And the value of this is nothing but 2V0. Is it okay? Come here. At the ending we are getting positive terminals, positive 4. Again come here. Here it's directly given V0. So we can take V0 here. No problem at all. V0. Here. Again we are getting 12. And at the end 0. Okay. We can simplify this first. Minus 4I minus 2V0 plus V0 minus V0 plus 16 equal to 0. Equation 1. Now if you will observe this equation, we are having two unknowns, two variables, but we are having only one equation. So to get the values of these unknowns we need another equation. So can we make equation from this given data? See here the V0 is given. V0 is given having polarity like this. Now in this circuit current is coming. See, current is coming. Due to this current the voltage drop will be like this. Is it okay? And the value of voltage drop will be, tell me, 6I. Fine. Why the polarity will be this? Higher, this is higher potential, this is lower potential, because current is coming into this element from this side. Okay, so entering terminal will be at high potential and the ending terminal will be at the lower potential. So this V0, the polarity of V0, if you will observe, is given the opposite of this. So this V0 is nothing but minus of 6I. Is it? If the V0 polarity is given like this, then simply we can say V0 equal to 6I. But here the polarity is opposite to each other. So V0 is nothing but minus 6I. Okay, now we are having two equations, two unknowns. Okay, so I'll put the V0 value here in this equation. So minus 4I minus sign already given here, and V0 is nothing but minus 6I plus 16 equal to 0. Now see, minus 4I minus plus 6I plus 16 equal to 0. Is it okay? Now 2I equal to minus 16. Okay. Now come, I is nothing but minus 8 ampere. So this minus sign indicates that the polarity you assumed for the current, or the direction of the current, whatever you assumed is wrong, and the actual direction will be from this side. Okay, first they were asking for the I, so you have to mention here I equal to minus 8 ampere, not plus 8 ampere. Okay, minus 8 ampere, because we have to consider the direction by default clockwise here. Now come to the V0. Once we find out the value of V0, I, we can find out the V0. V0 is nothing but minus 6 into minus 8. It will be 48 volt. Is there any problem? It will be 48 volt. I hope this one is clear to you. Now they are asking for the I and V naught. Both are here, 48 and minus 8. This is our answer. I hope this one is clear. It's very easy actually. Come to the next. Find the current and voltage in the circuit shown in the figure. Again, dependent source problem. They are saying find out the current and voltage in the circuit shown in the figure. Where is the voltage? Here. The voltage is given. Here I naught is given. Okay. Can we apply the nodal analysis here? Because it will be easy to apply nodal analysis. I already told you here we are having only two nodes in which one is grounded. So we are having only one node over here. Okay. So we'll be having only one equation. So see, I assign the voltage across here. Now apply the KCL at node A. By applying KCL at node A. Node A. So here the incoming current, and we assume the incoming current minus I naught, minus 5 I naught. Here the outgoing current I naught is given plus I naught. In this branch minus 3 is coming, equal to 0. Okay, at this node we are having 3 branches, so we will be having 3 terms in one equation. Minus 0.5 I naught plus I naught, it will be 0.5 I naught equal to 3. So I naught is nothing but 6 ampere. Once we find out the value of I naught, we can easily find the value of V naught. Okay, because V naught is nothing but this 4 multiplied with current, Ohm's law. 4 into current. 4 current is 6, so I'm having 24 volt. Clear? Very good. This is very easy again. Now come to the next one. Obtain V1 through V3 in the circuits. See, this V1, V3 we have to obtain the values. Okay. See, this one is also again very interesting problem. Okay, I'll take it on fresh page. The given problem is (24 volt). Here we are having V1. The circuit is like this. Here we are having 10 volt battery again. Here also we are having 12 volt. In this branch, across this we are having V3. Here in this branch we are having V2. The polarity of V2 is given like this. This is the circuit given in the question, and they are saying find out the V1 and V3. Friends, if you will observe this circuit carefully, no resistance values are given here. What it means? It means we don't have to do anything here like KCL equation. Will not get any equation because the parameters are not given over here. So it indicates that it is the very easy problem. How? Simply I'll apply the KVL in the circuit. Okay, see if in this outer loop I'll apply the KVL. I'll write the voltage equation, suppose, in this outer loop. So I'll be having only one unknown quantity and all are known. So it will be very easy to find out the V1. How? See. Okay, I'm going to find out. From A I'm starting, and at A I'll come. Okay. First I'm going in this direction, I'm getting minus V1. I'm writing the voltage equation because KVL is nothing but the voltage equation. So I'm getting minus V1. Okay, fine. Again I'm keep coming here, going forward like this. I'm getting minus 10. Minus 10. Okay, fine. Here minus 12. I'm getting minus 12. Okay, fine. I have to go to the A only. Here I'm getting 24. Okay, fine, 24. Is there any other voltage given in the circuit apart from this? No, only V1 is unknown. And the value of V1 is now 22 plus 24 equal to 0. So V1 is nothing but 2 volt. Is it okay? V1 is nothing but 2 volt. Once we find out the value of V1, we can easily find the value of V3. How? Again, I'll apply the KVL in this circuit now. This circuit. Take it X. So I'll apply now KVL in A, X, dA. Okay. And starting from A, getting minus V1. Minus V1 value already I have 2. I'm coming here from X to this side. I'm getting minus V3. Okay. Minus V3 over here. Okay. I'm getting minus 12. Fine. Minus 12. At the end I'm getting plus 24 equal to 0. Here only one unknown in the equation. Minus 2. Minus 12. Minus 14. And plus 24. I'm getting 10 minus V3 equal to 0. So finally V3 is nothing but 10 volt. I hope this is clear to you. Very simple circuit. Okay. So this is the answer. So we have done this problem. It's very easy problem. Right. Come to the next now. Determine the currents I1, I2 and I3 in this circuit. Now I think it's easy to find out for you people, right? So this one is for you. Find out this, okay? You can apply KCL over here, nodal analysis. By nodal analysis, easily you can do it, okay? And the question is asking for I1, I2 and I3. And I1, I2 and I3 are given with directions, okay? Now come to the next one, for the transistor circuit. Now I have chosen one question from transistor also. Simply we are going to apply the KVL here also, but see some parameters. Beta, this is the beta for transistor and that is 100 given. Okay. VB is given, base to ammeter voltage drop 0.7 volt, and determine V0 and VCE. Where is the V0? Here is the V0, here is the VCE. So for the transistor, friends, I think you people know about this. The emitter current is nothing but, okay, this is the NPN transistor. The emitter current is nothing but IC plus IB. Okay, and IB is very less, so IE is nearly equal to the IC always for the transistor circuits. Is it clear to you? Now another formula is given, and that is this IC is beta IB, where IB is nothing but the base current. Here this is the base current IB. This is base region, this is collector region, and this one is the emitter region. So the current in collector is IC. Current in the emitter is IE. Is it clear? And IE is beta plus 1 of IB. Is it okay? So you can see this IC and IE, these two terms are nearly equal to each other, right? See this. Now we'll solve this circuit. Can I apply here KVL in this circuit? In this circuit, yeah. Up to here in this circuit, this one, up to this junction, we are having only IB in the circuit, and after this the current is IE. Okay. So please, while solving, we'll keep this point in mind. Okay. Wait a minute. Fine. So I'm going to apply KVL here. This is IB and this one is IE. Okay. Apply the KVL. Apply KVL over here. 5 plus 5 find minus 10k IV plus VB is given. This drop is given here in the question 0.7 and the sign will be minus 0.7. Why minus? Because we are the outer terminal is the negative terminal. Come here. Here, see. And the question is asking that find out the V0 and VCE, correct? Now come here. Here the voltage drop is 200 minus 200 into IE equal to 0. Is it okay? Now see, can we find out the value of IE? If we are able to find out the value of IE, this V0 is nothing but this 200 multiply with IE simply. This V0 is this one, right? Okay. So yes, we can easily identify or we can easily find out the value of ammeter current by replacing IB. How I'll replace this IB? Because I know IB beta plus 1 is nothing but IE. Is it okay? Beta's value is given 100. So this IB 101 is nothing but IE. So I'll I'll replace this IB by IE by 101. So 5 minus 10k into IE divided by, it's 101, I'm taking it's 100 nearly, so it will be easy to cancel out, minus 0.7, here minus 200 into IE equal to 0. Only one unknown is there and that is IE. So when you will simplify this, so you will get, we can easily find out the value of IE. So when you will solve this equation, your IE will be nearly 14 milliampere. Okay. So IE is 14 milliampere. So what is the value of V0? We'll put the value of IE here. So it will be 200 into 14 milliampere. Okay. So it will be 2800 into milli. So finally 2.8 volt. The value of V0 is 2.8. Now the second one they are asking for the VCE. Now we'll apply the KVL in this outer circuit. So we'll get the value of VCE. Okay. What is the value of V0? We get 2.8. Now apply the KVL here. I'll start from here. 500 with negative sign because I assume the current direction IC is nothing but the IE, that is 14 milliampere. Okay, fine. Here I'm getting VCE. This is the positive sign, this is the negative sign. So minus VCE. Okay, fine. Here I'm getting plus minus 2 point, so minus 2.8, and this is the ground. Everything is okay. So VCE is nothing but minus 2.8 minus 500 into 14 million. Okay. So you will find, we'll get something VCE and solve it. Okay. It's up to you now. So friends, this is all about to this lecture. In the next lecture again we will see some problems and we'll finish this unit. Okay. We'll meet in the next video lecture. Till then, take